At this point, our mathematical model is completely defined, and let's get answers to solve it numerically and calculate selected variables at selected points. And so the variables we are interested in, so these are our selected points, and these are the selected variables that you're interested in. Answers is putting in some additional parameters that I will ignore in this discussion for the sake of simplicity, and they should all be equal to 0. So to do that, I will highlight solution in the tree and click solve. At this point, okay, so answers would have set these degrees of freedom at this node to 0, and then it would have solved derived the necessary algebraic equations and solve them to get the degrees of freedom at these two nodes. And so now we are ready, so we have the numerical solution, and the rest of it, everything else we do will be in part of post-processing. And at this point, we can go into solution information, and if you do Control F and search for element type, okay, it says the element type that was used is beam 188. And if I go into the help and search for beam 188, okay, over here, you can see that it is a 2-node element. That is, so you don't have the mid-side nodes, even though answers was saying we have a total of 5 nodes. That's how I confirmed it. And you can take a look at the other information on this page. For instance, it gives you, how the slenderness ratio affects whether you're using Euler-Bernoulli or Timoshenko. And for our slenderness ratio, essentially, we can assume that, the model that answers using is Euler-Bernoulli. So we have the selected variables at selected points, and let's do the post-processing. Before that, save your project.